Hello, am I audible? Okay, so let's begin with it. Good afternoon to all participants. I am Purva Durukkar, your host for the session, and I would like to thank all of you for joining us in this webinar on finding solutions to COVID-19 challenges using Arduino, hosted by National Service Scheme Committee of Vidyalankar Institute of Technology, Mumbai. Okay, so let me start with a brief introduction to our today's session. Learning new skills is essential to combat all challenges. Today, for us, the major challenge is COVID-19. The rise of COVID-19 has made us realize the importance of social distancing and for automation wherever necessary. There will be increased need for interactive electronic projects, and using Arduino makes the task so much simpler. So today's session comprises of a complete understanding and implementing various projects using Arduino. Before that, let me give you an introduction about what exactly NSS is. The National Service Scheme, abbreviated as NSS, is an Indian government-sponsored public service conducted by Ministry of Youth Affairs. It aims at developing students' personality through community service. NSS is a voluntary association of young people in colleges and universities. As the motto says, not me, but you. The program aims to instill the idea of social welfare in students and to provide service to the society. Following this vision, the NSS Committee of Vidyalankar Institute of Technology organizes various events such as orphanage teaching, beach cleaning, tree plantation, various vaccination drives, and many more. The NSS unit is mentored by Mr. Praveen Gharge, Assistant Professor in the first year Engineering Department. Now comes the moment. I am glad to introduce to you our special guest of honor, Mr. Mohit Gujjar. Presently, Mr. Mohit Gujjar is working as an assistant professor in Electronic Telecommunication Department of VIT Vadala. His domain of expertise is embedded systems and IoT. He is into teaching since 2016. He has also worked on 3 industrial projects. To his credits, he has published 7 papers in international journals and conferences. Along with all these achievements, Professor Mohit Gujjar conducts many skill development workshops on topics such as embedded systems and IT, Python for data science, image processing using OpenCV, etc. We will be communicating with you all through the chat box. So if you have any questions, please keep posting them in the chat session. Your questions will be answered by the end of the session. And e-certificates will also be provided only to those who fill the feedback forms, which is present in the description below. So without wasting our time, let's get to the webinar. I would like to call upon Mr. Mohit Gujjar to take over the session. Over to you, sir.
Thank you so much, Purva, for your good words. I hope everyone is doing fine and they are safe and healthy. Let us dive into our session. Okay. So NSS VIT presents Solution to COVID-19 Challenges using Arduino. In this particular webinar, we will first discuss something about coronaviruses and then the challenges which we'll be facing after lockdown. We will discuss the basics of system designing and then we'll go for Arduino Uno platform, or rather entire Arduino platform. We'll simulate the solutions for those challenges on online simulation tool called Tinkercad. So let us start. Coronavirus. When we look this virus in microscope, we'll be able to see these type of crowns on the surface of surface of this virus. These crowns in Latin are called as corona. hence the name coronavirus. So this coronavirus family contains hundreds of different viruses. Out of those 100 viruses, 6 of those viruses are harmful for our humans, and rest of the viruses are not harmful for humans, but they may be harmful to other animals. The 7 type of virus which is now we are facing was discovered, and hence initially it was named as novel coronavirus because it was not known previously to us. This was the new type of virus which was discovered. So in 2003, similar disease called SARS spread due to some other coronavirus. The first patient of coronavirus which was discovered on 31st December 2019 in Wuhan, China. So this was reported to WHO on 31st December 2019. At that time, the disease was reported as some kind of pneumonia of unknown cause. So the name was announced by WHO on 11th February 2020 as coronavirus disease, and it was first found in 2019, so it is called as COVID-19. So this is name of the disease, that is COVID-19, and name of the virus is severe acute respiratory syndrome coronavirus 2, that is SARS coronavirus 2. So name of the virus and name of the disease, these are two different things. For an example, we all know that HIV is a virus and AIDS is name of the disease, right? So we always name a disease and the virus causing that disease. Okay, so this COVID-19 disease has right now affected 216 countries, and it has been declared as a pandemic by WHO on 11th March 2020. Now this is a very important thing which we should consider. See, WHO does not declare pandemic to any type of disease so easily. So declaring a pandemic means that the disease is spread all over the globe. The disease is spread all over the globe, and currently we do not have any solutions or treatment for that disease, and there are a lot of deaths due to that disease. So WHO has had last time declared a pandemic in 2009. We all might be remembering H1N1 flu. So last pandemic was declared in 2009, and it was swine flu. So swine flu was also spreaded across the globe, and it had also taken lot many lives. But this pandemic is the status as pandemic is there for short period, and for H1N1, that is swine flu, the status was removed on August 2010 when the virus was in control. Similarly, COVID-19 right now is declared as pandemic, but once the virus comes under control, then the status of pandemic will be removed. The similar type of one more example I would like to give was of AIDS. So this was declared as pandemic in 2005, and it was having that status till 2012. The point which you need to remember right now is, even if these diseases like swine flu, H1N1, and AIDS, so even if these diseases are not pandemic right now, still we see the traces or some cases of swine flu or swine flu or other type of viruses at different instance of times. So these viruses spread across the globe, and these viruses stay at particular different geographical regions and may occur from time to time. So even if we find a cure, treatment, or a vaccine to COVID-19, this virus will stay for longer period of time. And we have seen such type of statements from WHO time to time, right? So with this note, we should find some changes in our day-to-day behavior so that we can avoid the COVID-19 virus, or we can avoid us getting infected from COVID-19 virus. So what those changes or what those things we should remember is, we should maintain social distancing, right? As declared by WHO, we should have at least 1 meter distance between us and others. Why this is important? Because whenever someone is talking, whenever someone is coughing, sneezing, the virus particles may travel up to 1 meter. So we should have at least 1 meter distance between us and others. Now all those who are in front of us, we can have 1 meter distance, but we cannot see at our back how many people are there at our back, and whether there is distance between us and them, or whether there is 1 meter distance between them. So how to challenge this difficulty? Another challenge is, now in public places we have soap dispensers. So can we create a contactless soap dispenser, so that whenever someone comes near to that dispenser, only then the soap will be available without any contact. Similarly, contactless hand sanitizer, similarly contactless temperature measurement, and designing spray tunnels. So these are some challenges which we have to face after our lockdown, right? Because coronavirus is going to stay for a longer time. So can we find solution to these challenges using Arduino? We will see this in our workshop. I hope everyone is following till this point, right? And I hope everyone is getting why there is a need to design such systems even after coronavirus comes under control, right? So now, before diving into Arduino platform, let us first see some basic or let us revise some system designing fundamentals. So whenever we are trying to design a particular system, first we need to find what type, or we need to define what type of system we are going to design. Suppose if I want to monitor temperature of a particular room, so in order to monitor a temperature, we we will be needing some different sensors, like temperature sensor in this case, right? We might be needing some input devices, for an example a keyboard or anything else. So there are different input devices, so we have to find out different sensors, different input devices, and depending upon the input from these devices, we need to take some decisions, right? So these decisions will be taken by a controller. And how a controller will take decisions is by writing a code and storing it into a controller, right? So we will be needing a controller, and then depending upon the decisions, the output of the controller will change. So we need to decide what output devices are there, or what output devices we should consider. So all these things comes under system designing. So initially, when we proceed with system designing, first we look at which all different inputs are there with us, or rather which all different input sensors we will be needing. Then we decide different output devices, and based on our requirement, we select a particular controller. This is one approach of designing a system. Once this is done, the most important part comes is power supply design. So we have to find how much power my different modules, input, output, and controller is going to require, and depending upon that, we design our power supply. So in this first approach, we design our system first, find out the power requirement of that system, and then find out the power supply for that. So there is one more approach. If the power supply is constrained, like in embedded systems, mostly if we want to have a standalone embedded system, the power supply requirement, or there are constraints of power supply. So depending upon our power supply, we select different low power sensors, low power input devices, low power microcontrollers, and low power output devices. So this is the second approach of designing a system. So these are some basics of system designing. We will dive into all these basics one by one. So first, let us discuss something about microcontrollers. For all those who do not know this term, or just don't know the basics of this term, let me tell you in detail. So microcontroller is nothing but an integrated circuit. It is nothing but an integrated circuit which consists of different blocks or different components, right? So these different blocks are nothing but RAM, ROM, interrupt controllers, oscillator and timing control unit, IO ports. But most important unit is a microcontroller, sorry, microprocessor. Now what happens is, why do we need a microcontroller? As we discussed, microcontroller will take decisions depending upon the program you feed into it, right? So this program has to be stored somewhere, isn't it? So we need different types of memories to store our program. So as we all know, ROM is a non-volatile type of memory. That means whenever we remove power supply and again we give power supply to it, the contents of ROM do not change. So we store our code in ROM. This code is executed by our microprocessor. So our microprocessor executes the instructions one by one, taking from this ROM. Now why do we need a RAM then? RAM is a volatile memory, but it is very fast. So we store the temporary variables. Like in our program, suppose if we write int x, if we write this, so x is my temporary variable and values of this x will be stored in this RAM. So CPU will take inputs from ROM, or rather instructions for ROM, the variables which are created, temporary variables from RAM, and then based on the program, it will decide what the output has to be. Now suppose we want to integrate or interface a sensor to our microcontroller. So for that, we need to have different IO ports. So this microcontroller, depending upon our code, looks for different sensors and takes input from those sensors or different IO devices. So we need different IO ports as well, and we also need oscillator, timing and control unit for generating different square wave pulses for this microcontroller to work. So basically, this microcontroller contains different blocks, and each and every block has some or the other importance. Now, while selecting a microcontroller, we need to remember that depending upon our application, how much size our code will be, how much size of our RAM will be. So all these things we need to consider before selecting a controller. Now controllers or microcontrollers are manufactured by many different vendors like Intel, Atmega, so Atmel, PIC. So there are many different vendors. So depending upon your application, you select a particular microcontroller. Okay. So now we will come to different sensors. How to select a sensor. So what is a sensor basically? Sensor is nothing but a special type of transducer. Sensor is nothing but a special type of transducer which converts any physical quantity into an electrical signal, right? So transducers, as you all know, they convert one form of energy into another form. But sensor is a particular case which will convert any physical quantity like distance, temperature, speed, any physical quantity into some kind of an electrical signal. So those electrical signals can be voltages, current, resistance, inductance, capacitance. So these are the output signals that a sensor can generate. So there are different types of sensors. Some sensors change their output voltage depending upon the input physical quantity. Some sensors change their current, some sensors change resistance, and so on. So I have given some examples of sensors whose output parameter change depending upon the input, right? So these sensors are available, these different sensors are available in market. But in order to integrate this sensor with our microcontroller, we need to convert these output parameters like current, resistance, inductance, and capacitance into voltage form, because microcontroller can read, or the input pins of microcontroller can read change in voltages, right? So these sensors, we have to convert the output of these sensors into voltage form. So if suppose I am having a sensor like photodiode and whose output current changes with respect to intensity of photons, so I will change this current into voltage variation using I to V converters. So there are different circuits available to convert current into voltage. Similarly, if I'm having RTD, so or thermistor or a load cell whose output resistance changes with respect to input physical quantity, then this resistance we change into voltage by using Weybridge setup. So there are different circuits available which are used to convert one form of energy into voltage. But always what we do is we convert different type of quantities into voltage before giving it to our microcontroller. Okay, so I hope this point is clear. So microcontrollers, what they do is they take inputs from different sensors, input devices, and depending upon the code which is written into it, they'll take a decision and then it will generate an output for the output device. Now the advantage of Arduino specifically, or the Arduino platform, is that the sensors which are available, we don't need to design the signal conditioning circuit for those some sensors. So there are ready-made modules available in for Arduino. So these kind of modules are available for Arduino, which you can directly integrate it with your Arduino modules. So if you see carefully, there will be different types of sensors like IR sensor or PIR sensor or smell sensor, or rather there are different types of sensors, and already ready-made modules are available in market, which you can directly integrate it with your Arduino. So the output of all these sensor modules are directly compatible with Arduino. But these modules are of two types, or the output of these modules are of two types. One is analog type and one is digital type. So whenever we try to integrate a sensor with microcontroller, usually the output of sensor is very low. So voltage will be in millivolts range, current will be in milliamperes range. So our controller needs voltage in the range of 0 to 5 volts to detect it, but the output voltage and current of our sensors are very less. So we need to design signal conditioning circuits. But these ready-made modules which are available, they directly give the voltage in the range of 0 to 5 volts and current in proper range, which can be detected by different controllers. So this is the advantage of Arduino module. So these modules can give output in analog form or digital form. But microcontrollers can read only digital signals, that is variation in ones and zeros. It is not possible for a microcontroller to read an analog signal. So what we need to do is we need to convert this analog signal into digital signal, and the process of doing that is shown over here. So our analog signal first is sampled at different intervals of time. So these are different intervals at which it gets sampled, and we find out what is the voltage at that particular instance. So these are different voltages at particular instances. On y-axis you may see different levels. So what we do is once we sample our signal, those voltages are brought close, or those voltages are quantized to a particular level. So suppose voltage at this point is 5.2 volts, we will quantize it to 5 volts. Okay, so this is called as quantization, and then every quantization level is represented by a binary value, right? So similar thing is done over here. So if you can see, this is the voltage which is very close to 12 volts. So we will quantize this voltage to 12 and we will generate a code for it. So these are different quantization levels, and on left side you can see different codes for each level. So what we do is this analog voltage is sampled at different intervals, and for every interval a particular digital value will be generated. So for this interval we will generate a digital value, and then this entire digital value can be given to our microcontroller. So this process is called as A to D conversion. Now the thing is, if you see here, actually the value was 11.8 or something, and we changed it to 12 volts. So some information was lost by while doing this. So this is called as quantization error, right? In order to avoid quantization error, what we do is we try to increase quantization levels. So when we increase quantization levels, the code or the output of each level also increases. Okay, and the formula for that is 2 raised to n. So where n denotes your number of output bits and your quantization levels. So suppose if I am having 4 output bits, so n is equals to 4, so quantization levels will be 16. The Arduino has an onboard A to D converter, and the Arduino is of 10 bits. So for every sample, 10 different bits will be generated, or 10 different digital bits will be generated. So the quantization levels in Arduino are 1023. So I hope you are getting these things and I'm not confusing you more. But the main thing is, right now the sensor modules can give an analog output or a digital output. So this analog output we need to convert it into digital. So this is called as an A to D conversion, and our Arduino has onboard A to D converter in it, right? There are many cases in which we at the output side we need an analog signal, and as microcontroller is a digital device, it can only generate digital signals. So microcontroller cannot generate an analog value at the output. So separately we need to interface a DAC, that is D2A converter, digital to analog converter. And remember, DAC is not there on board. On any Arduino board there will not be a DAC. You will find ADC on board, but there will not be a DAC. So you need to interface and DAC module externally onto your Arduino board. I hope these things are clear to you all, right? So now with these basics, we will dive into our Arduino platform. Okay. So what exactly is an Arduino platform? So Arduino is nothing but it consists of different boards which are development boards, and it consists of an IDE which is used to program different development boards. Okay, development boards are of like Arduino Uno, Arduino Nano, Leonardo. So there are many different development boards which you can select. So whenever you hear a term Arduino, Arduino is just a platform. This platform contains development boards, and it contains a software which is used to program those development boards, and that software is called as an IDE. Okay, integrated development environment. So using this IDE, we program all these development boards. Now, why this Arduino platform is so famous? Because it is an open source platform, and because it is an open source platform, and hence we can add different external boards which are not manufactured by Arduino into this Arduino platform. So there are many different examples like ESP boards, ARM boards, many different boards are there which you can add into this Arduino platform, and we can program it using this IDE. Now it becomes easier for a developer point of view. Even if our board changes, we have to make very little or minor modifications in our program, right? I know all these things might be overwhelming right now, but trust me, you will understand this once we look at Arduino. Okay, once we see programming of Arduino, right? So over here I am having an example Arduino Uno board, right? So if you see over here, this is an Arduino Uno board. This is an entire development board which is having a microcontroller in it. So can you see over here, this is an Atmega 328 microcontroller which is designed and developed by Atmel, right? So this is a microcontroller. Now this Arduino board is used to develop different applications. The program we store in this microcontroller is loaded from our computer or PC through this USB type B port. So over here we are having a USB type B port. Okay, so This USB type B port is connected to PC using a cable, and through PC we program our Arduino Uno using this. Okay, this is a power supply over here. This is a port used to connect an external power supply which can support 7 to 12 volts. We have a reset switch over here. We have a crystal on this board which is of 16 megahertz. Then we also have a voltage regulator over here. So there are different components which are present on this particular development board. Now the main components which we need to understand are these pins. These are the pins which are very important for us. So these pins, let us see over here. Over here they have written digital pins, right? So from pin number 0 to pin number 13 we are having different digital pins with us. Now what do you mean by digital pins is you can give either 0 volt or 5 volts output from these pins, or you can take input as 0 volts or 5 volts input from on those pins, right? So these are digital pins. Similarly we are having analog pins, right? Analog pins, as we discussed previously as well, there is an onboard A to D converter, right? So we can connect our analog signal on these analog pins. So we are having A0 to A5. These are different analog input signals. A to D conversion can happen on board. So we can give analog input in the range of 0 to 5 volts, and this A to D converter will convert it into 0 to 1023 equivalent. Okay, so 0 to 1023 equivalent, it will convert it into it, right? So input voltage is suppose 0 volts, and if we try to read from this analog 0 pin, we will get value as 0. If the input voltage is 5 volts and we try to read this analog voltage pin A0, we will get 1023. Similarly, if the input is suppose 2.5 volts, and if we read this value on this pin, we will get somewhere around 512. So don't worry, we are going to see all these things in detail, but right now only thing you need to remember is it has separate digital pins and separate analog pins. Okay, this thing is very important. Now, as we discussed, these digital pins can be used as input pins as well as output pins, isn't it? So we need to initialize it, whether we are going to use it as an input pin or output pin while programming. But these analog pins, as we have only ADC on our development board and we don't have DAC, these analog pins are only used as an input pins. Okay, it does not have any dual functionality, whereas these digital pins are multiplex and they have different dual functionalities. So analog pins can only be used as input pins, so we don't need to initialize them while programming. Okay, see, these concepts again we are going to revise while programming, but right now just try to understand this. Okay, also over here if you see, we are having different power pins. Now what do you mean by power pins? So these power pins are used to generate different voltages, or they are used to provide power to external modules like sensor modules or input output modules. So we have 3.3 volts output, we have 5 volts output, we have 2 ground pins, and this is V in pin. So this V in pin is used to give voltage input to our Arduino board as well. So if you notice carefully, voltage can be given or the power can be given to this entire Arduino board using 3 ways. First is using this USB type B connector from our computer. Another is using this connector, power supply, and we can give 7 to 15 volts, sorry, 7 to 12 volts, and V in. So any of these three input power we can select to give power to our entire board and our controller. Okay, I hope this is clear to you all, right? So we can generate different output signals, that is 0 volts or 5 volts on these digital pins, isn't it? we can take input, we can input different signals, digital signals on these digital pins. Also, there is one more functionality of these digital pins. We can generate PWM signals. Now everyone knows what is PWM. So PWM is nothing but changing the on time and off time of a pulse, right? So if we change the on time and off time of a pulse, we the average voltage that we get at the output changes, right? So if on time is less and off time is more, the average voltage will be somewhere around 25% of our actual voltage. Similarly, if we increase the on time, that is if we increase the duty cycle, the average voltage increases. So over here you can see different examples of different duty cycles, right? So this type of PWM signals can also be generated using these digital pins. So if you see, there is a marking on these PWM signals. So all the digital pins which are having these markings can generate PWM signals for us. Okay, and we can specify the duty cycle of our PWM by writing code into our controller. Okay, or we can write specific code to specify the duty cycle. I hope you are getting this right. So we will see examples of coding our microcontroller or our Arduino to see or to explore all these functionalities. But let me just revise once. The digital pins have different functionalities. It can be used as input pin or output pin. The analog pin has only single functionality, so it can only be used as an input pin, right? So now let us come to Arduino programming. Okay, so this Arduino programming is done This Arduino programming is done using a software called as Arduino IDE. This is the software, okay? That is Arduino IDE. And whenever we open this software, we can see two different functions. One function is called as setup function and another function is called as a loop function, okay? So these are two different functions. Now, for this, you need to have some prerequisite knowledge of C language, okay? And you need to understand what do you mean by function. So function is nothing but set of instructions. So we usually write instructions in this function, okay? We write instructions in these functions, and when we ask it our IDE to execute, these instructions which are written inside the functions will be executed, okay? So you can see there are two different functions, one is setup and one is loop. Now, this loop function, as name suggests, will execute all the instructions which are written into this loop function infinitely. Okay, that is the reason why this function is called as loop. This is a special feature of Arduino IDE. Okay, so this is the special feature of Arduino IDE, that all the instructions which are written inside this loop will be executed infinitely. Why this is done? Why this is done is because mostly we design a system using Arduino for different embedded applications. Okay, so embedded applications are nothing but the applications which are used for a specific task, like AC, fridge, washing machine. So it should keep on executing some or the other thing. So all the instructions that we write inside a loop will be executed infinitely. And similarly, we are having a function called as setup. This function will also have different instructions inside it, but these instructions will be executed only once. And what will be the flow of execution? Initially, the instructions which are written inside setup function will be executed, and those instructions will be executed only once. Then the execution will come to this loop function, and the instructions that we write inside this loop function will be executed infinitely. Okay, so I hope you are getting these two functions. One is a setup function and another is a loop function. This setup function and loop function, what are the instructions we should write in these functions? We will see now. Okay. So suppose, let us take an example of interfacing. Let us take an example of interfacing a simple LED to our Arduino. So right now I'm going to Tinkercad platform, but I have not given you any, uh, uh, I mean, idea about Tinkercad. So don't worry, we will discuss this platform later on. I'm just trying to give you an example. So suppose we are trying to interface an LED with our Arduino. Okay, so this is our Arduino Uno board, and this is our LED, right? So this LED is connected to pin number 13, and so anode is connected to pin number 13 and cathode is connected to ground, correct? And if we want to program our Arduino Uno module, so in that case, let us try to program it. Okay, so over here, as you see, we are having two different functions. One is setup and another is loop. So what will we write in this setup function? Okay, so what will we write in this setup function? So as we said, we are connecting our LED to a digital pin, isn't it? So when we connect our LED to a digital pin, these digital pins are having two functionalities. One is input functionality and another is output functionality. So we have to specify whether we are using as it as an output pin or input pin. So how do we do that? Is using this pin mode instruction. Okay, so there are different instructions for programming. One of the instruction is pin mode. We specify the mode of the pin, whether it is an input pin or output pin. So over here we are specifying that pin number 13 on which we are connecting anode of our LED is my output pin. So this is the syntax, that is pin mode. So pin mode is an inbuilt function of Arduino wherein which we are passing two parameters. One is 13, that is pin number, and another is its type, that is input or output. Suppose we are interfacing a sensor on pin number 4, right? So suppose we are interfacing a sensor on pin number 4, then we need to specify we need to specify similarly pin mode. Pin number 4 is my input pin, so this we have to specify. Okay, this will be included in our setup function. So as we discussed, the execution will happen like, initially it will go into the setup function. It will execute the instruction whichever is written in this setup function once, and then it will go to the loop function, right? So in this loop function, what we want to do is we want to blink this LED for 1 second infinitely. Okay, first let us see the output and then we will see the instructions which are written. So if you see, this LED is blinking infinitely. Okay, continuously it is blinking on and off, and there is no end to this function. Why this is so? So over here in this loop function, what we are writing, we are using digital write as a function. What this function is, as we are using digital pins, we are specifying that digital write which pin number 13, as we are using this pin number 13, and what value we need to give. We have initialized that pin number 13 as an output pin, but whether we need to give 5 volts or 0 volts, we have to specify it through this digital write function. Okay, so pin number 13 we are giving, or we are trying to give 5 volts, so we will specify high over here. Then we are giving a delay of 1 second. So delay is another function which in which we are specifying a parameter 1000. So we are specifying time in milliseconds. Okay, so it will generate a 1 second delay. Then we are specifying pin number 13 to be low. What low indicates that 0 volts will be generated over here, and this LED will turn off. And then again delay of 1 second, right? So this is how we try to write program to our Arduino, and we have to use different instructions for that, or different statements. So the most important statement is pin mode. Pin mode is used to specify whether a particular pin is an input pin or an output pin, and this we have to specify it particularly for a digital pin, because digital pin has dual functionality. It can be used either as input or as output. We don't need to specify pin mode of an analog pin. Okay, then then so pin mode we have to specify for digital pins. Then we need to specify in our loop whether we are trying to give output on these digital pins or input. So the command for that is digital write, high or low. This is the command for that. Okay, so we specify whether we are trying to give a high value or a low value using this digital write instruction. Okay, if we are trying to use the digital pin as an input pin, then the command will be, yes, you might have guessed it right, digital read. Okay, and we just need to specify a pin. So suppose I want to read pin number 4 of my Arduino, I will specify digital read pin number 4. Okay, and whatever is the value on that digital pin will be stored in a variable that we specify. So don't worry, we are going to see where all these things in detail when we program our Arduino board. Okay. Similarly, we are also having analog read option. Okay, so the instruction for that is analog read and analog pin. So it can be either A0, A1, A2, and so on. Correct. So we are having analog read option, right? And we also discussed that these digital pins have an option. These digital pins have an option to generate PWM signals, right? So why do we use PWM signals usually is, suppose if I want 2.3 volts at the output, Arduino is not able to generate 2.3 volts, but we can generate an average voltage using PWM of 2.3 volts. So for that, we need to change the duty cycle, isn't it? So for that, the instruction given in Arduino is analog write. Okay, so analog write pin number and the PWM values. So which pin numbers we have to specify over here? These digital pins which are having this PWM functionality. Okay, so these pin numbers we have to specify, and then what should be the duty cycle of my output wave, that we will be specifying in the instruction. Okay, so I hope these points are clear. Now you might ask, ki, if I am writing an instruction of analog write, why we are specifying digital pins? The reason is that the analog pins are only having input functionality and not the output functionality. So output functionality, input output functionality is only there on digital pins. So PWM signal will also be generated on these digital pins. Okay. So these are different basic instructions which you need to know before starting with Arduino programming. Okay. Now we will dive deep into Arduino programming by using a platform called as Tinkercad. Okay, so this is the Tinkercad designed by Autodesk. You need to first log in into Tinkercad. You can search on Google about Tinkercad. You will get a web page. You can log in into that web page, and you need to go in the circuits part of this Tinkercad. Okay, so if you have to click over here to go into the circuits part. Okay, and then you have to click on create a new circuit. So a blank screen will appear over here, and over here you can design different Arduino projects, right? So we will see how to do that. So this will be a blank screen which appears on Tinkercad. So over here, if you see, this is the section where we can find different components. We have resistors, capacitors, and many different components. And we are having some sensors, that is photoresistors, photodiodes, and we have some ready-made sensor modules also available over here, which is ultrasonic sensor, PIR sensor. So these are different sensor modules also which are available with us, right? And we are having some output like LED bulbs, neopixels, right? On top of that, we are having this Arduino Uno module, right? So we can drag and drop this Arduino Uno module over here, and we can select different type of inputs for it. So suppose if I want to turn on and off a LED. Okay, so I can select LED. I can change color of that LED. Let us change it to orange. Okay, or rather we can change it to blue, right? And we can connect this LED to a particular pin of Arduino. Let us connect to D3. We can change the color of this wire, and cathode we can connect it to ground. Okay, and change the color to blank blue, sorry black. Okay, and then how to code this Arduino. So over here we are having a code section. By default, this code section will have these blocks as a type. We have to click on it and we have to select text. See, these things are there only on Tinkercad. On Arduino IDE, by default, we program it using text. Okay, so this is, we are doing it on Tinkercad, so we need to select all these things first, right? And over here you can see that they have already given an example code for us, right? So we can change this example code. We can select pin mode of pin number 10. So we are using pin number 10, which is a digital pin, so we have to initialize that digital pin as an output pin. Okay, and then we have to write digital high, and this pin, so we have to give these instructions: digital write, pin number and its value. We have to give a delay. Similarly, digital write, pin number and its value. So all these instructions which are written inside loop will be executed infinitely. So one instruction at a time will be executed. So first this instruction will be executed, then this, then this, then this, then again the execution will come to this instruction. So if we start the simulation, let us see what we get. Okay, so we can see that this LED is blinking after every 1 second. But there is some caution which is also displayed over here. What is that caution? Current through LED is 50.5 milliamperes, while the recommended current is 20 milliamperes. So as we are not including any current limiting resistor, it is saying that this LED will glow definitely, but due to high current this LED may get damaged, isn't it? So this is the advantage of a simulator. We can see what can happen to our circuit beforehand, isn't it, before actually implementing it. So now we can take a resistor and we can select the resistance of this resistor. So let us select a 220 ohms resistor and let us put this resistor in series with our LED. Okay, so now we are putting this in series with our LED. So there is no need to change the code, isn't it? Because the code will remain the same. Only thing is we are adding a resistor in series with it. So now if we run, the caution is not there over here, isn't it? So this current limiting resistor is limiting the flow of current and our LED is blinking after every 1 second, isn't it? So let us again take a look at this code which says digital write. Okay, so we are using this digital write command, correct? So digital write command. Okay, now suppose if I want the intensity of this LED to change. Okay, if I want to change the intensity of this LED, so in that case what we can do is we can give a PWM signal to this LED. In order to give PWM signal, the command which I need to write is analog write. Okay, analog write instruction or analog write command will generate a PWM signal over here. So let me simply write for int I less than 1023, int I, let us initialize it from 0, int I is equals to 0, I less than 1023 and I plus plus. So this is a simple C code in which we will be writing analog write the value of PWM over here. Okay, and let us give a small delay of 10 milliseconds or rather 100 milliseconds, and let us close this for loop. Right now we are trying to understand this how analog write function works. So this analog write function will generate a PWM signal of a particular value, okay, and this PWM signal, due to its change in duty cycle, will change the intensity of this LED. So let us see what output we get over here. So if you see, initially the intensity of LED increased from 0. So let us give 500 milliseconds delay. So intensity is slowly increasing. It might not be visible in the presentation, but the intensity is changing over here slowly and gradually, right? So there are different circuits which I have made basically to test this particular thing. So I'm connecting a pot over here. This pot is giving some analog value over here. So this analog value, we can look at into the code. So this analog value is connected to an ADC or analog input pin, which is A0. So if you notice carefully, A0 input I'm using this analog read A0, but I'm not initializing this analog input pin in my setup because A0 is only an input pin. A0 can only be an input pin. So we don't need to specify it in our setup. Okay. So we will start the simulation, and you can see if I change the value of this pot, the intensity of LED is changing. I hope it is visible in this simulation, or I mean in this online webinar, but the intensity is gradually changing as we change the value of the pot. Okay, so this was the simple program to understand how analog signal is read by our Arduino. Okay, so this was some basics of Arduino programming. Now let us dive more deep into it by finding the solutions to some of the challenges that we discussed of COVID-19. Okay, so first solution, let us find a soap dispenser which will automatically dispense soap if anything comes in range or in close proximity to it. So for that we will be using a PIR sensor module. So this PIR sensor module has three different types of inputs. One is three different types of pins. One is a signal pin, which is an output pin. One is a power pin, which needs 5 volts, and one is a ground pin, which will need which has to be grounded. And if anything comes in proximity of this PIR sensor, it will generate a digital signal. Hence we are connecting it to digital pin, and once controller detects a change in value on this digital pin, it will change the motor or a servo motor which is connected over here. Okay, so it will rotate that servo motor. So I've written the code over here. So this is the code. In this code we are reading our PIR sensor pin. So we have declared PIR sensor pin as pin number 4, and we are reading this sensor pin. If this pin is high, we are calling rotate function. So this rotate function I have defined it over here, right? When we click on start simulation, so it will first initialize the stepper motor, and now see, this is the entire range. This is the entire range of my PIR sensor. If there is any movement in my range, my my servo motor will be rotating entirely. So it will dispense the soap once. Again, if there is a movement, my servo motor will rotate once, and it will again dispense the soap, right? So this is just a prototype. We need an actual Arduino. We'll write the program using Arduino IDE, and we will burn our program in this controller, and then we will connect our PIR sensor and servo motor, and we will try to see the output. Okay, so this was one example in which we automatically try to dispense soap or hand sanitizer, if anything comes in the range of a PIR sensor, right? So we can implement this in crowded areas, or rather areas like malls, restaurants, so that whoever wants to wash their hands will get soap, or the soap will be dispensed without touching the soap bottle over there, right? So another example is maintaining social distancing, right? So as we all know that as recommendations of WHO, the distance between two persons should be at least of 1 meter. So we can use this type of sensor. So, and suppose we connect this type of sensors at the back side, and we can find whether someone at our back is keeping proper distance or not. So this is an ultrasonic sensor which gives me the distance of the obstacle. So if the obstacle is in less than 100 centimeter, that is less than 1 meter, it will it will ring this, it will start this buzzer. Okay, so right now the obstacle is in range of 234 or 250 centimeters. If the range comes beyond below 100 centimeter, if the range comes below 100 centimeter, you might notice that this LED is on and this buzzer is started, isn't it? Now if range increases, the buzzer will stop buzzing. Again, if range reduces beyond 100 centimeter, it will start buzzing, right? So this was one more simple example of social distancing, how we can implement social distancing. So we also have one more example of hand washing. So what are the recommendations of WHO is that one should wash hands for at least 20 seconds, but while washing hands, usually it is difficult for us to find out whether 20 seconds are completed or not. So in that case, what we can do is we can include an LED strip close to the handle or close to our tap, and whenever someone comes in close contact of that PIR, this is our PIR sensor. When someone comes in contact to that, whenever there is a movement, this LED will glow, keep on glowing for 20 seconds. Okay, so for 20 seconds this LED will keep on glowing, and then it will stop, right? So this will indicate that 20 seconds are completed, and you can stop your washing your hands, right? So these are some examples of the challenges which we can tackle, or using the system or Arduino. Okay, I would like to show one example which is generated, or which is designed by one of my student, Ashish Kamath. He has designed this system for he has designed this system for spraying sanitizer, which is called as spray tunnel. Okay, so
Hello everyone, my name is Ashish Kamath from Vidyananda Institute of Technology. This is a simple project made by me. It is called a disinfectant shower. I call it the anti-corona ring. The operation is quite simple. The ultrasonic sensor here is programmed to detect obstacle within zero point 0.5 meters, and when it does detect, it will mostly people. It turns the relay on for 10 seconds, meaning that it switches on the motor pump which sprays the disinfectant liquid through a spraying nozzle for 10 seconds. After the 10 seconds is complete, LED turns on for 5 seconds, indicating that the disinfection is complete. Let's see the process. Here is the ultrasonic sensor. It will turn on the motor relay for 10 seconds. After 10 seconds, LED light glows, indicating the disinfection is complete. Thank you very much.
Okay, so this was one example. Similarly, we can implement different examples and at different places, and it becomes very much easier by using Arduino circuit or Arduino development board. Now you might say that, sir, is it required always to use this entire development board in our project? I mean, all we need is a microcontroller. Can we use this microcontroller in our system? Yes, it is absolutely possible. This is just a development board. Arduino Uno is just a development board. We will use this Arduino Uno for proof of concept, and then we will design a PCB in which we will mount this programmed microcontroller, and that PCB can have pin holders for our PIR sensor and our LED strip or different input output devices, and we can generate output, or we can generate a particular project using that. So similarly for all these things. Now I guess the code of all the projects is not properly visible. I just now got a feedback that the code is not properly visible. I will try to uh, give code for all these different projects. I'll create a repository for it, and I'll forward the code for all these projects to all the participants along with the e-certificates. I'll forward it to you all. So do you have any doubts, or can we discuss the question answer sessions? Can we go for the question answer sessions? Miss Purva, are you there?
Yes, sir. So the first question is from Sachin Pathak. What is the reliability of Arduino family for longer duration products in terms of power consumption and latency?
Okay, a very good question. But reliability, uh, so power consumption we can find out using, just a minute, I'll show you one example for that. So suppose if you want to find power consumption, so on this particular platform Tinkercad, there is an option for multimeter. We can get multimeter, we can connect this multimeter in series, and we can find the amperage or the current consumed by different components, and we can find the power consumed by this entire system. So as I said that Arduino is just a development board. While designing our system, we have to design our own PCB, and then we have to find out the power calculations, right? The another reason for not using this Arduino development board in our project is we have to use these jumper cables, and these jumper cables reduces the reliability, because if there is a loose connection or something, or if particular cable is not working properly, then the reliability of our system reduces, right? So for prototyping we can use this Arduino board, and the for programming we can use the Arduino IDE. Once it is programmed, then we can remove the controller from this. Sorry, I am not sharing the screen, I guess. Okay, so this multimeter I was talking about. So this multimeter we can connect in series, and then we can find out the current requirement of all different sensor modules. So once we are done with that, we can remove our controller. Once we are programmed our controller, we can remove our controller, and we can mount it in our own systems to increase the reliability of our system, okay, or our entire project, right? So I guess your doubt is clear, Sachin.
Okay, so the next question is by Jay Hekshetty. Arduino C language is used.
Yes, right now we use only C language, or there is a support for only C and C++ language. So Arduino IDE also supports C++, which is used for object-oriented programming, right? So we can have different classes and instances of that class, and we can have different methods. So it supports C and C++ programming, but Arduino is also working on Python support. So soon, within 1 year or so, we will be looking at Python support or Python language for coding Arduino. But right now, we are having only C and C language support for Arduino. Okay,
The
so the
next question is
software tool, sorry, yes. So Anupama is asking which is the software tool. So the software tool we are using is called as Tinkercad. Tinkercad is an online platform. It is not an offline platform. It is an online platform wherein which we need to log in or sign up, and we need to create an account. And by going over Tinkercad, so once we go into our account, we have to go into circuits tab. We have to go into the circuits tab of the Tinkercad software or the Tinkercad platform, and then we can design different systems. So this is the online platform which we are using. So now this Tinkercad is actually present for very long time. But you might ask, why, sir, this is not that famous, isn't it? Tinkercad we have not heard as much as Arduino. The reason is Arduino module on its own is very cheaper. So you can buy Arduino entire development board of Arduino for somewhere around 200 300 rupees, and you can buy different sensor modules for 20 30 100 rupees. So within 400 500 you can test entire system on Arduino board itself. So mostly people prefer directly hands-on experience on Arduino. That also, one more disadvantage of Tinkercad is that there are not many different modules available on Tinkercad, and we cannot add external modules on Tinkercad, right? So that is one more drawback of Tinkercad. So then why we are covering this Tinkercad in this webinar? That is because during this lockdown period, it is difficult for you to get hands-on or find Arduino board, find different modules. So that is the reason why, if you want to get started with Arduino, we are having this Tinkercad platform, okay, to just get the sense of Arduino, and later on you can dive more detail by getting Arduino board. Okay, so I hope your doubt is clear. Can Arduino handle 12 volt 2 ampere? Yes, Arduino board can handle 12 volts. So just a minute, I'll share my screen again. So Arduino board can handle 12 volts if we give input to Arduino board using this particular connector. So 12 volts 2 ampere adapter you can connect to this particular connector, and there is a voltage regulator over here. So this voltage regulator will regulate and bring that voltage down to 5 volts, or which is required to different peripherals. So yes, definitely Arduino board, or rather Arduino Uno board, can handle 12 volts 12 volts and 2 amperes adapter, but you have to connect it over here. You cannot connect it to V in. The voltage input for V in, the voltage input for different input voltages vary. So you have to be careful with that. Okay. Okay, so how long you can run? So I'll just read for others also, if it is not visible. If I make a project, how long can I run my whole system? That is without any form of heating issues or some other sort of problems. So see, the thing is, the Arduino Uno board has have different protections in it, right? So this controller, there won't be any issues regarding heating of this controller, because excess current will never flow through this controller. The excess current can flow through these PWM pins. So there are different Darlington pairs type of circuit available over here, which takes the current directly from our regulator to the digital output pins. So voltage will be given from here, but the current, excess current requirement can be generated through this regulator itself. So your Arduino controller will not be heated, right? So it depends on your external circuit, like which sensor you are using, which input output device you are using, and how the circuit designing is. It depends on that, the heating effect will depend on. So suppose if you are using some output sensor which is taking high amount of current, somewhere around 500 600 milliamperes, and using that much current, it gets heated up. So that depends on your circuit, external circuit, how well you are trying to manage that heating. So your controller on this development board will never get heated, but the external module can get heated. Okay. Which is the best Arduino boards for carrying out IoT project? A very good question. So right now, the board which is usually used in industries as well is called as an ESP platform. So ESP8266 is a very good board for IoT projects, but that board is not designed by Arduino. It is designed by a third party, designer, and that board is easily available. It costs around 200 to 50 rupees. ESP8266 module. And the beauty of Arduino platform, as we discussed, is that we can add external boards into our Arduino platform. So there is an option of, just a minute, I'll show you. So there is an option of adding an external board by going into board manager. So you can add an external board. See over here, I have added node MCU, that is ESP8266, right? So ESP8266 module I have added, and this ESP8266 module is currently the best for IoT applications. But Arduino has also recently launched few IoT related boards which are also very good, but it are not widely available. So those boards are not widely available in India right now, but definitely in coming some time those boards will also be available. But the right now the best platform is ESP platform, ESP. Okay. Okay, very good question. How to connect the relay with Arduino to run with pump? So relay has basically two different parts. One is an input part and another is an output part. And input part uh, is used to select or to turn on or off the output, right? So input part basically has either 5 volts as an input or 12 volts as an input, depending upon which type of relay module you buy. So the just just a minute. If I'm having a relay, I'll show you an example. Okay, so relay module is not available properly on Tinkercad. Let me explain you in PPT. So So this relay, I hope my screen is visible, will have an input part and output part. Okay. So this relay acts as a switch. This relay acts as a switch. So if I give 5 volts over here, this switch will be closed and this pin will be connected over here, right? And if I give 0 volts, the switch will be open and the connection will be lost. So suppose I'm having an AC signal over here and I'm having a bulb. So if I want to turn on this bulb, I need to give 5 volts over here at the input of my relay. Okay. So when I give 5 volts, this connection will be completed and this AC signal will be given to my bulb and my bulb will glow, right? So now how to interface this relay with our Arduino? What we can do is the just a minute. So we can connect the input of relay to any of the digital pin of my Arduino. And suppose if I generate 5 volts, that is if I give logic high over here, that particular input will give 5 volts and the output corresponding to that particular input of the relay will be getting turned on and the 230 volts will be connected at the output side. Which is better, Arduino or Raspberry Pi? Okay, so this is a tricky question. Arduino and Raspberry Pi are used for different applications. Okay, Arduino is a controller board and Raspberry Pi is entirely a computer on its own, right? So both are better. You cannot say Arduino or Raspberry Pi. Depending upon your application, you have to select between Arduino and Raspberry Pi. But trust me, Arduino and Raspberry Pi both are better in their own ways. Raspberry Pi is an entire computer. Okay, so if you connect a monitor, keyboard, mouse, and if you install an operating system in your Raspberry Pi, it is a computer. But Arduino is not a computer. Arduino is just a development board. It has a controller, and Arduino is used for designing different systems. Okay, so if I would like to explain in the more detail, so Arduinos can be used in projects like remote controls, AC, fridge, TV. All these things are designed for a specific task. है ना? We cannot use remote control to make a call. राइट रिमोट कंट्रोल का काम क्या है जो भी की प्रेस करेंगे उसका इक्विवेलेंट आईआर सिग्नल जनरेट करना राइट सो फॉर अ स्पेसिफिक टास्क इफ आई वांट टू यूज आई विल यूज आर्डिनो but for a generalized task if I want we usually prefer microprocessors or computers so mobile phones is an example of Raspberry Pi type of systems which is entirely a computer है ना so mobile phones we can use for calling functionality as well as mobile phones can be used as a remote control so if there is an IR blaster in it we can use it as a remote control so mobile phones can be used for different functionalities right so Raspberry Pi is a computer Raspberry Pi can be used for generalized applications but Arduino is used for specific type of applications okay so both are better in their own ways. Okay, again a very good question. How can we use Arduino to control a high power system like agricultural pumps? So as we all know, Arduino works on electrical circuits, right? I mean electronic circuits, and high power pumps works on electrical circuits, right? So there has to be I mean isolation between electrical and electronic part, right? So the best way to do is to use a relay, correct? So electronic and electrical systems can be isolated using a relay. So the relay example, the relay question which someone asked in previous question. So you can use a relay in which input side you can give DC signal, and at the output you can generate an AC signal, or you can control an AC signal. Okay, so you can use a relay for that. Okay, again a very good question. Does every Arduino board has the same microcontroller? No, it depends on different Arduino, depends on different boards. So right now Arduino Uno has Atmega 328, but Arduino Nano has a tiny version of Atmega. So depends on different boards, there are different controllers. But the beauty of Arduino is that the code which you write for different controllers, like we are using Arduino IDE, isn't it? So the code which you write for Arduino Uno will remain same for even I mean Arduino Mega, Arduino Nano, or any other type of external boards as well. So that is the main, or that is the very good point of Arduino, right? Only by changing the pin numbers, you can use the same code on different boards, provided those functionalities has to be there on those boards, right? Where does log gets saved? So by log, I assume that you are talking about log while programming, if there are any errors in the programming. So if there are any errors in the programming, my Arduino IDE will specify it over here. So so if you can see this section which is down, this green part, so below this green part the black section is there. So if there are any errors in my code, it will show it over there, but it will not log any errors. Okay, it will not log any errors. And if we want to log something into our Arduino, then we have to write a code which will store different values in our ROM. Okay, EEP ROM is there in Arduino, right? So in our EEP ROM we can store different values and we can log different values in our Arduino, so that those values remain inside our controller every time we give power to our Arduino. Okay, so how much, again, how much, this question depends on what is the size of your ROM of microcontroller. Usually it is 4K, 4 kilobytes and so on, 128 kilobytes and so on. So it depends on different microcontrollers, or depends on different boards which microcontroller it is used. Okay, again a very good question. Can Arduino take audio inputs from for automating appliances? Arduino can take audio inputs, but you need to convert that audio into digital, right? So you can design a circuit for that to convert the see, basically audio input is nothing but a voltage signal, continuous analog voltage signal. So you need to convert that analog signal into digital and then give the digital signal to your microcontroller, isn't it? Now, one more advantage of Arduino is that there are external shields available. Okay, what do you mean by shield is, suppose this is my Arduino Uno board, and we get an external shield which we can mount on top of my Arduino Uno board, and on that shield we can, there are options of connecting directly a 3.5 mm jack or an audio input. So that shield will take care of converting my audio input and giving it to my Arduino Uno board. So there are many shields available. One of this shield is Arduino, audio input shield. One of the shield is Ethernet shield. So you can directly connect an Ethernet cable to your Arduino Uno by mounting an Ethernet shield on top of it. So if you Google it, you will easily find out different shields. So audio shield, if you Google audio shield for Arduino Uno, you will see the pictures of it. Okay. So yes, it can take audio signals. Which is best to design, a quadcopter, Arduino Uno, or LilyPad? Okay, so Arduino Uno, if you select directly, there is no RF module on Arduino Uno. So definitely you can select a particular version of Arduino Uno platform which has onboard RF module on it. So it will help you to give commands wirelessly to your quadcopter. Okay, so it is better that you select a Arduino Uno variant. It can be any variant which has onboard RF module on it, right? So and there are many different variants for it. Also, one more thing which you should consider is how much current I mean, those modules are going to consume, right? So low current consuming modules you have to select for quad copy. Can we connect current transformer output directly to Arduino boards? Okay, but why would you like to? I mean, it depends again on application. So current transformers output, do you want to supply more current to your external peripherals? For that reason you want current transformers. So in that case, you can create an external Darlington pair, and then you can give current transformers output to your Darlington pair. Through Darlington pair you can give it to your external peripherals. But I feel if you specify this question in more detail, I guess I can solve, I can give answer to this in better way. Can we go for next question? What type of Arduino is used for Wi-Fi modules or for Wi-Fi applications? So as we discussed, ESP8266 and ESP32. So ESP platform, basically, it is not, ESP is not an Arduino designed board, but we use ESP platforms for Wi-Fi applications. Okay, so ESP8266 has only onboard Wi-Fi module, and ESP8266 has Wi-Fi as well as Bluetooth module on a single board. Okay, so we use ESP modules for that. How can we compare Arduino to Node MCU? So Node MCU is what I am specifying about ESP8266. So if you would like to compare Arduino with Node MCU, so all the functionalities of Arduino is also present on Node MCU. So if you consider Arduino Uno board, so Arduino Uno board has an onboard A to D converter. On Node MCU also there is an onboard A to D converter. Arduino Uno board has digital output pins. Node MCU also has digital output pins. But what is the advantage of Node MCU? Node MCU has onboard Wi-Fi module. So ESP8266 is nothing but a Wi-Fi module which is available on Node MCU. So Node MCU is always one hand upper than Arduino module, and also it is very compact and current requirement of Node MCU is less. But one drawback of Node MCU, which I find in most of the applications, is Node MCU has only one single input analog pin, whereas Arduino Uno boards and other Arduino boards have many different analog input pins. So suppose if I want to interface different analog signals to my development board, so Node MCU has only one analog input pin. So if that is okay with you, then obviously you have to prefer Node MCU boards. How can we use error exceptions in Arduino? Uh, okay, so these error exceptions are mostly, it is part of try catch type in Python. So in Arduino, while programming itself, see, so as we said, we always use Arduino for embedded applications point of view. And whenever we are designing an embedded system, we always need to carefully design all the embedded systems depending upon all the possibilities of input. So there should not be any exception. So we have to write our code in such a way that there should not be any exception. So exception handling is not part of embedded system designing. It is part of in general system designing, which usually you can find it in Raspberry Pi and other systems. Okay, so I guess I have cleared that part. If you explain UART and I2C protocol. Okay, so as it is a webinar, we have very less time, so I was not able to explain UART and I2C protocol. But in general, what I can specify is, just a minute, I'll share my screen. Okay, so what is a UART? So basically, we are having TX and RX pins over here, right? So just a minute. So we are having TX and RX pins over here. So these TX and RX pins are used for serial communication. Now, why do we need serial communication is because we send one bit at a time, right? So suppose this is my one module, and this module I'm trying to communicate with my Arduino Uno, right? So this Arduino Uno can send data serially to second module, correct? So this is serial communication. Now the disadvantage or main drawback of serial communication is that this module might work at different frequency and this module might work at different frequency. So the clock on Arduino Uno is 16 megahertz. The clock on, suppose this is my 8051 module, okay, the clock on 8051 module, it can be 12 megahertz. So as these two devices are on different frequencies, uh, the synchronization becomes very difficult in these two devices. So serial communication is usually called as an asynchronous type of communication. Asynchronous means clock of both the devices are not same. Okay, so so it is an asynchronous type of communication. And universal asynchronous. UART, universal asynchronous receiver and transmission. UART is the protocol used for asynchronous type of communication, in which what we do is, if suppose this is one module and this is another module, both of the modules are working at different frequencies. Using UART protocol, we set frequencies of both the modules as same. जैसे कि हम लोग पहले ही डिसाइड कर लेंगे कि भाई तू मेरे को ये फ्रीक्वेंसी पे सेंड करना डेटा, एंड मैं इसी फ्रीक्वेंसी पे रिसीव करूंगा, एंड दैट फ्रीक्वेंसी इज कॉल्ड एज baud rate in UART. Okay, so baud rate, suppose if I say 9600, so if this device is transmitting at 9600 hertz, so 9600 bits per second, then this device will also receive 9600 bits per second. So this is called as baud rate, and this is the main core of UART. Okay, so whenever you are using UART TX-RX pins for communication, you have to set baud rate of your transmitter module and receiver module the same. Okay, so this is UART, and I2C is it is usually called as I2C, inter-IC communication. So this is to communicate between two different integrated circuits. So I2C protocol is also very much used in industries, and so I2C protocol is also supported by Arduino. In fact, I2C, SPI, and UART, all three protocols are supported by Arduino. So let me show you. So if you see, these two pins are dedicated for I2C. So these two pins over here are dedicated for I2C communication, and these four pins over here are dedicated for SPI type of communication. Okay, so we can probably have some another session for in detail of SPI and I2C, SPI, I2C, and UART communication, which is our serial protocols. Okay, but I hope I have given some idea about it. Any other question? So
Thank you, sir.
can we, sorry?
I think we're
Yes.
done with the questionnaire session.
Okay. So that is all
So that
from my
was
side.
yes, sir. Thank you, sir. That was truly an amazing session by Mohit. Hope we all have learned something new, and this will surely make us and help us come up with something which will help in develop our society. I, on behalf of the whole NSSV team, thanks sir for this session and all the participants for their valuable time. I'd also like to remind you that the feedback form is in the description box. Please fill the form to make sure that you get your e-certificates. Again, thank you for attending the session. Please subscribe the channel as well, as the video will be uploaded soon. Thank you so much.